Okay, so in previous videos we were developing the concept of a bearing A from B and B from A. So let's drill into that concept and look at some harder questions. Before we do that, let's recap on what we mean by a bearing. Okay, so there's three things about bearings we need to know. First thing is that a bearing is always measured from north. So I'm going to write measured from north. Okay, so for example, the direction northeast is 045 true bearing. Okay, so the second thing is bearings are always measured clockwise. Okay, measure southeast is 135. True bearing. Okay, and finally, the third thing is that bearing is 3 digits and the T at the end denotes true bearing. Okay, so let's have a look at this concept A from B, B from A. So I'm going to write A from B and B from A. Okay, so we've got two positions, A and B. So the first thing we need to do, I'm going to do this in blue, is we need to introduce a north on both of them. Okay, so let's connect them up. Okay, so I'm just going to draw in these directions. Let's put A from B using green and B from A using this turquoise blue. Okay, so we begin A from B. Okay, so we're going from B to A. Okay, so this bearing here measures A from B. Okay, so let's draw in B from A. Okay, this is going to be this direction here. Remember, they're always clockwise, always from north, and always 3 digits. Okay, I want you to do the second one, which is X from Y and Y from X. Okay, pause the video and draw in those two bearings. Okay, so you should have done that now, and I'm going to draw X from Y in red, and let's do Y from X in burgundy here. Okay, so the first thing we do is we draw the north in for both of them. North, north. Okay, we need to connect the two distances. Okay, that's done. So let's do X from Y. Okay, so X from Y is going to be this bearing here. And then Y from X is just simply going to be this. Okay, so just to finish this off, this is quite an important concept, and it's something that students make mistakes in and have many misconceptions. Okay, so I want you to draw M from N and N from M. And let's denote colours. Let's do yellow and it's blue. Okay, pause the video and draw those two bearings in for me. Okay, so you should have done that now. The first thing we do is we draw north for both positions, M and N. We connect them up. Okay, so we need to draw M from N. Okay, so that's going to be this bearing. And then N from M is simply going to be this bearing here. Okay, so hopefully you've understood that concept and are able to apply it to more complicated bearings questions. Okay, so let's have a look at some past paper questions. Okay, so this appeared on the Maths General for 2018. So pause the video and see if you can do the question. Okay, so let's have a go at doing this question. What is the bearing of town C from A? Well, north. So the bearing of town C from A is going to be this clockwise bearing here. Okay, now we know that town A is due north of town B. Okay, due north is just one way of saying 180 degrees. Okay, so the bearing measuring clockwise is going to be 180 plus 34, which is 214 true bearing. So it's going to be C. Okay, that's pretty straightforward. Okay, now, this is not on the paper, but see if you can have a go at working the bearing of A from C. Pause the video and see if you can do this. Okay, so the bearing of A from C. Now, we need to put in some more information. Now, these two norths are parallel. Okay, we need to remember our Z angles here. Okay, if we have two parallel lines, these two angles are equal by alternate angles. The same is true here. This angle is equal to this angle. Okay, so the bearing of A from C is going to be this clockwise angle here. Okay, it's a bit messy. Let's redraw that in. Okay, simply going to be this clockwise, which is just simply 034 degrees true bearing. Okay, so let's have a look at another example. Okay, pause the video and see if you can do this. Okay, so hopefully you've done this. The diagram shows towns A, B and C. Town B is 40 kilometers due north of town A. The distance from B to C is 18 kilometers, and the bearing of C from A is 025 true bearing. It is known that angle BCA is obtuse. Okay, so what is the bearing of C from B? Okay, so let's draw in our north. Okay, now the bearing of C from B, they've already drawn this in here, which I'm sure has helped a lot of students, because many students would not have been able to have drawn that bearing in. Okay, so we need to use a little bit of trigonometry here. We know that angle A is 25. We know that side A, I'm going to write, is 18. And we know that C here is an unknown angle, but we've got side C. Okay, now sometimes if we can find the second angle, we can find the third angle using the rule that there's 180 degrees in a triangle. So let's do that then. Okay, so let's use the cosine rule, and with the angle on top we get sine A over A is equal to sine C over C. Okay, we need angle C, so if you rearrange this by multiplying both sides by C, we're going to get sine C is equal to C sine A all over A. To find angle C, we do inverse sine inverse C sine of A all over A. Okay, if we input those values that we know that C is 40 kilometers. We know that angle A is 25, and we know that side A is 18. Okay, if we do that on the calculator, we get 69.91 degrees to 2 decimal places, and we can write in that is 70 degrees. So we now see 70 degrees. Okay, so using our angle facts, we can deduce that this is 85. And we can subtract 180 minus 85 to get 0.95 true bearing. Okay, so make sure you can understand everything we've done there, and let's have a look at another question. Okay, so this is the HSC General 2017 bearings question. Pause the video and see if you can answer part I and part II. Okay, so hopefully you've done that, and many of these bearings questions use trigonometry, so you should be familiar with both the sine and the cosine rule. Okay, so let's label everything. So we're asked to calculate the shortest distance from A to school C. Okay, so the shortest distance there is going to be side B. Okay, the shortest distance between 2 points is always going to be a straight line. Shortest distance between A and B is going to be the straight line A and B. Okay, so let's label this triangle. Okay, we know that C is 5, and we know that, A 13, and this is angle A. So we're going to use the cosine rule, which is b squared is equal to a squared plus c squared minus 2ac cos b. Now many students ask, how do we know why to use the cosine rule? Well, if we are given only one angle and two sides, that indicates that we need to use the cosine rule. The sine rule wouldn't work here. It wouldn't work here because we need to know the length and we don't know two angles. Okay, so let's work this out. Okay, so I've taken the square root of both sides. A square root of a square just leaves b, and let's fill this in. So we've got 5 squared plus 13 squared minus 2, 13, 5 cos of 135. Okay, on your calculators, that should give 16.91 kilometers to 2 decimal places. To the nearest kilometer, that is 17 kilometers. Okay, determine the bearing of C from A. Okay, so C from A is going to be this bearing here. Okay, so we need to know what angle this is going to be here. I'm going to do that in okay, let's just do it in blue. Okay, so we need to know that angle there. Okay, so we can use the cosine rule. Okay, so let's do sine A over A is equal to sine B over B. If we rearrange that, we're going to get A is equal to the inverse of A sine B over B. Now I'm assuming that you can do the algebra here. It's not an algebra tutorial, so you should be able to rearrange that trig equation. Okay, so let's input everything. So we've got sine to the minus 1, A, which is 13, sine 135, all over. Okay, I'm going to use 16.91. I'm not going to use my 17 because that will give us a rounding error. Okay, so use the previously unrounded value. Okay, so that will give an angle of 32.93. A is equal to 32.93 degrees, and we need to add 180 to that. Okay, so this angle there is 32.93. But we still need to measure this distance here, look. So let's add on 180 degrees. And that gives a bearing of 212.93 true, and it says to the nearest degree. So that's going to be 293 to the nearest degree. Okay, hopefully you've understood that and you're able to apply both sine and cosine rule to bearings problems. Okay, so let's have a look at this question. The diagram shows a radial survey of a field A, B, C, D. Okay, now there's a trick to these. There's a trick to these. If we subtract these bearings, we're going to get the angles of the individual triangles. Let me demonstrate this. Okay, so if this is bearing 051, that means the angle is 51 degrees because we're measuring clockwise from north. Okay, so the difference between 160 and 51 is going to give this angle here. Look, the bearing of 160 is all of this here. So if we subtract them, we're going to get the individual angles. Okay, so if we do that all the way around the circle, we'll get the individual angles. This is 51. This is 109. This is 64. This is 76. And we don't know this angle. Okay, now let's choose a particular angle. Let's choose this angle. Okay, so we've got a bearing of 224. We subtract 160. We're going to get 64. Okay, so we need to find angle AOB. So I'm going to do this in green. Okay, so angle AOB is this angle here. Angle AOB. Okay, so there's 360 degrees in a circle. We've got all the individual angles. So 360 minus 51 plus 109 plus 64 plus 76 should give our bearing. Okay, so 360 minus 300, this gives 300, gives 60 degrees. Okay, so this angle here is going to be 60 degrees. Okay, write that in very small. Okay, so 60 degrees. Now, as I said previously, angle AOB is this thing here. We already know that this angle here is 51. So angle AOB is going to be 60 plus 51, which is 111 true bearing. Okay, so hopefully this has made bearings easier for you to understand. Continue to do past paper questions, and you should have no problems with bearings in the exam.